This assessment asks us to give 5 ways that we can make the carboxylic acid on screen. In many ways, this is just a problem to remind us of the things we've seen before for synthesizing carboxylic acids. Let's start with my favorite, and that's going to be the one that allows us to, at the same time, make a carbon-carbon bond. So we can start with this Grignard reagent. In step 1, we can react with CO2, and step 2, an acid quench. At the end of that, we should have this carboxylic acid. Over here on the right, we'll put our various oxidation reactions. So we can start really with the methyl group by itself. We can start with an alcohol, a primary alcohol, or we could start with an aldehyde. And depending on which one we start with, our reaction, our reagents will be slightly different or can be slightly different. If we want to do this full exhaustive oxidation of the so-called benzylic carbon, we'll use a system involving chromic acid, water, and because this has to oxidize that methyl group all the way to a carboxylic acid, we're going to heat this reaction to drive it farther. In contrast, when we start with the primary alcohol, we can simply use chromic acid and water. Heat's not as important for doing that oxidation of the alcohol all the way up to the carboxylic acid. In the case of oxidizing the aldehyde, we're already halfway there, I guess, to the carboxylic acid. So we can use a milder reagent, in this case, a buffered sodium chloride solution, NaClO2, usually T-butanol to help with solubility, and as we said, a buffer. That will result in a carboxylic acid. These are probably the most common ways that we would do this. The last one we'll do is one that wouldn't be used quite as often, but we'll put it on our screen anyway, and that is to do the oxidation of, for example, an alkyne. This might be done using a reagent like potassium permanganate in a reaction that's going to be reminiscent of osmium tetroxide, but again, pushing that reaction even farther with water and heat. This will also produce a byproduct of formic acid, but the carboxylic acid of interest will be the major product in this reaction.